Hi student, today topic 11th standard physics lesson 2 kinematics part 6 class. So students, today we are going to discuss about equations of motion. It's nothing but equations of uniformly accelerated motion by calculus method. So this is a basic kinematic equations, these four equations. So we go to discuss about. Let's go to discuss equations of uniformly accelerated motion by calculus method. So student, let us consider an object. This is an object now at rest. So put the accelerator an object moving in a straight line, with a uniform acceleration or constant acceleration. Now here acceleration of the particle is a constant. Acceleration of the particle is a constant. For uniformly accelerated motion, some simple equation that relate displacement, time, initial velocity and final velocity. So acceleration of the particle are obtained. So students, now listen to it. The initial velocity of an object u at a time t is equal to 0. The final velocity of an object at a time t. This is a displacement. Displacement, yes. Okay. Now discuss first relation. Velocity time relation. Velocity time relation. Now tell me students, what is definition of acceleration? Acceleration is defined as changing velocity with respect to time. That is definition. Okay. Now draw the velocity time graph. So taking along two axes, x-axis, y-axis. Already you know that x-axis only independent of object. Now here independent object time. So time is along x-axis, velocity changing, that means dependent object, so along y-axis. Okay. Now the acceleration of a particle, so time here changing time and also velocity of the particle also changes. So the acceleration of an particle moving in a straight line. So student, now calculate slope. Draw the slope and calculate slope value. Slope is equal to changing velocity delta v with respect to time. Therefore slope is equal to delta v divided by delta t. This is a acceleration of an particle. A is equal to dv by dt. Changing velocity with respect to time taken. So students, the acceleration of an body or object at any instant is given by the first derivative of the velocity with respect to time. Therefore A is equal to dv by dt. Okay. Now this equation dv is equal to A into dt. dv is equal to A into dt. Okay. Now this equation both side and integrating. So students, so integrating on both side, therefore the integrating dv is equal to integrating A into dt. Now put the value of integrating value dv, changing velocity, initial velocity to final velocity. Now see the diagram. This is the initial velocity to final velocity. Now put the integrating value, lower limiter and upper limiter, u to v, and time, initial time 0 to final time t. Okay, now the value of integrating value of dv. What is the value of integrating value of dv? Already you know that integration of dx is nothing but x. So here integrating of dv u v, that is equal to integration of a into dt 0 to t. Integral of dv is nothing but v. This is the initial velocity to final velocity, and a is constant. The integration of dt is nothing but t, therefore 0 to final time. Now put the value of final velocity to initial velocity, v minus u, therefore a t minus 0, therefore v minus u is equal to at, and finally v is equal to u plus at. These equations are called a kinematic equation. This is a first relation is derived. This equation number 1. Next, second relation, displacement time relation. Now tell me students, definition of velocity. The definition of velocity is defined as changing displacement with respect to time. So students, the velocity of an object or body is given by first derivative of the displacement with respect to time. Therefore, v is equal to ds by dt. So now ds is equal to v into dt. Already we know that from equation 1, v is equal to u plus at. Now this equation substitute this relation, therefore ds is equal to u plus at into dt. So assume the initially at a time t is equal to 0, particle started from origin. So already you know that. Later time, that means final time t, if the particle displacement, further assuming acceleration is time independent. So now integrating on both sides. Now one step, rewrite this equation. ds is equal to u into dt plus a t into dt. Now integrating on both sides, therefore integrate of ds, that is equal to integration of u into dt plus integration of a into t into dt. Now put the value of integrating ds, changing displacement. Already you know that is the initial displacement. Now taking displacement time graph, t is along x-axis, displacement along y-axis. The initial displacement 0 and initial time 0. Therefore initial displacement 0 to final displacement s, and here u is initial velocity, but time will be changing, variable dt. Therefore 0 to t. Here also time variable a is a constant, 0 to t. Okay, now integrating that values. So integration of ds, what is the value? So s minus 0, s, that is equal to u dt. What is the integration of dt? T. That means integration of dx is equal to x. So here integration of dt is equal to t, ut plus a is constant, integration of t into dt. Now tell me from equation, integration of x power n into dx, that is equal to x power n plus 1 divided by n plus 1. So here integration of d into dt, t power 1 into dt, that is equal to t power 1 plus 1 divided by 1 plus 1. Therefore t square by 2. Now substitute here. Therefore s is equal to ut plus a by 2 into t square into t square. Are you clear, children? Okay. Now this is a second kinematic equation. So students, now write this second kinematic equation. S is equal to ut plus 1 by 2 at square. This is kinematic equations. Second equation, that is equation number 2. So third relation, velocity displacement relation. Now tell me student, the acceleration is given by the first derivative of velocity with respect to time. Therefore acceleration is defined as changing velocity with respect to time. Therefore dv by dt. Already you know that. Okay, now write this equation. A is equal to dv by dt. And displacement is multiply and dividing ds divided by ds, and rearranging this equation. A is equal to dv by ds into ds by dt. So already you know that ds by dt, changing displacement with respect to time. Therefore velocity ds by dt, already you know that. Okay, now substitute here dv divided by ds into v. Okay, then a into ds, that is equal to v into dv. A into ds is equal to v into dv. Now this equation integrating on both sides. Integration of a into ds, that is equal to integration of v into dv. Therefore now here variable ds, so integrating value 0 to s. Now changing velocity, therefore initial velocity to final velocity. Now what is the value of integration of ds? Is nothing but s. Therefore a into s, that is equal to, what is the integration of v into dv? Using integrating formula, x power n into dx, that is equal to x power n plus 1 divided by n plus 1. That equation using here. Therefore v square by 2. What is the integrating value? U to v. Therefore now substitute as is equal to v square final velocity to initial velocity divided by 2. Okay, then therefore similarly 2as is equal to v square minus u square. Therefore v square that is equal to u square plus 2as. So students, this is the third kinematic equation. This is a third kinematic equations. Are you clear? Next from equation 1 we can write, now this is the equation 1, v is equal to u plus at. Now can be similarly this equation at is equal to v minus u. So students, this equation, substitute equation number 2. Substitute in equation number 2. Now tell me what is the equation number 2? S is equal to ut plus 1 by 2 at square. Now this equation similarly S is equal to ut plus 1 by 2 at into t into t square. So this is a same thing. Now substitute at value. At value, that is equal to v minus u. Therefore S is equal to ut plus 1 by 2 v minus u into t. Then S is equal to ut plus 1 by 2 v into t vt minus 1 by 2 ut. Okay, now listen student, ut and minus 1 by 2 ut. So can be resolving this equation. Now listen here, ut minus 1 by 2 ut. Now taking LCM, 2 ut minus ut divided by 2. So this is a 2 times ut, this is 1 time, that is negative ut. So cancel and get the answer ut by 2. Now substitute here, therefore S is equal to ut divided by 2 plus vt divided by 2. Now here time is constant, taking outside, therefore S is equal to u plus v divided by 2 into t. So student, this is the equation of kinematics. This is the fourth equation of kinematic. So students, the four equation here I derived. Okay students, these equations and are called kinematic equations and using many practical applications. So students, it is to be noted that all these kinematic equations are valid only if the motion is in a straight line with constant acceleration. So students, that is a object moving in a straight line with a uniform acceleration or constant acceleration only. So it is a possible. And a oscillatory motion, for circular motion and oscillatory motion, these equations are not applicable. Understand students? This is a 5 mark questions. Note it down. And next topic, kinematic equations of motion under gravity. So students, already you know that for kinematic equation, four equation can be used to practical applications. So now here the practical example of straight line motion with a constant acceleration. In this motion of the object near the surface of the earth. So student, the near the surface of the earth, the know the acceleration value, that means acceleration due to gravity g is constant. All straight line motion under this acceleration can be understood using kinematic equations. So students, these equations of motion under gravity, there are two cases. First case, a body falling from a height h. So in this case I am going to draw the object from one point top of the hill. So this ball will be dropped down and moving toward the ground, is nothing but toward the surface of the earth. As it is falling freely in the top to bottom, this will be accelerated due to gravitational force A. Gravitational force of earth, which is acceleration due to gravity G. So students, now listen to it. This is acceleration of an object A due to gravity, acceleration due to gravity, that is nothing but G. A value is with respect to G, and see that acceleration due to gravity along y-axis. So this is x-axis and this is y-axis, object moving along y-axis. So student, so this is the x-axis, this is x-axis and y-axis, and the length of height, the one downward, this is a then the downward direction along y-axis, and the length height, that is height, that is equal to h, which is y value, that is h is equal to y, and ground, this is origin 0. So students, object moving toward the ground along y-axis, that is height h is equal to y. Sometime we call it is displacement, total displacement from top to bottom, that is s. Then acceleration of the object toward the earth A, and due to gravity, acceleration due to gravity G. Okay, then acceleration, you know, as vector format, we have go for component vector. Now write it, the component of vector A is equal to AXI unit vector, that means cap, plus AYJ unit vector plus AZK unit vector. And here the acceleration only along y direction, object are accelerated only y direction. So students, and all other component is 0. Which component will be 0? X component and Z component. Only object moving in the y axis. So AYJ unit vector, that is acceleration A vector, that is equal to GJ unit vector. So object is not moving along x and z component, that is z axis, only in the direction of y direction. So what do you do going this? Very simple in equation of motion discussed in early classes. So equations of motion is discussed here. Already you know that first equations of motion v is equal to u plus at, second equation s is equal to ut plus 1 by 2 at square, and third equation v square is equal to u square plus 2as. So students, these equations are major equations of motion in this instead of acceleration due to gravity. The acceleration of the object A, that is equal to acceleration due to gravity, A is equal to G. Let's me take this value in substitute equation number 1, V is equal to U plus AT. So after we get answer V is equal to U plus GT, because A is equal to G. So instead A, acceleration A is equal G. Substitute an equation 1 and 2. Y is equal to, Y is nothing but a S. ut plus 1 by 2 gt square. And one more equations, square of the particle, speed of the particle, that means v square. Square of the speed of the particle when it is at a distance y from top of the hill. So students, is given by v square is equal to u square plus 2gy. Are you clear? Okay. In this case of initial velocity of the object, u is equal to 0. Now understand student, the final velocity v, initial velocity u, the position of the particle and v square, and at any time t are given by the equation. So now here the position of the particle and initial velocity u is equal to 0. Now substitute from these three equations. These three equation. This is the first equation, second equation, third equation. Okay. After we get answer, v is equal to gt, y is equal to 1 by 2 gt square. And third equation, v square is equal to 2gy. Understand students? Okay. Then time. Then the time t, small t is equal to after get reach the ground, that is maximum time t. Then take by the time taken by the particle to reach the ground. So height y is equal to h. Now see from the diagram. What is the this is a the object top to bottom, that is a height h is equal to y, is nothing but from equations. Okay, now calculate the time period of the object. The particle reached the ground. Therefore, from equation y is nothing but h. H is equal to 1 by 2 g t square, capital T square. Now t square is equal to 2h divided by g, and finally we get answer t is equal to square root of 2h by g. So students, implies that greater the height, particle take more time. So height, it is a greater than the particle is more time to reach the ground. For lesser height, it take lesser time to reach the ground. Understand? Okay, then the speed of the particle when reach the ground. Now using square of the speed of the particle, v square is equal to 2gy. Now see, the speed of the particle when it is reach the ground, y is equal to h, can be found using equation, and get answer v is equal to square root of 2gh. This above equation implies that the body falling from greater height and have higher velocity when it is reach the ground. So student, when object can be thrown upward direction, the velocity of the object is decreases. After that, come to the ground, the velocity of the object, it is greater. So students, here higher velocity when it is reach the ground on the object. Okay, then free fall, it is very important to mark the motion of a body falling toward the earth from a small altitude, that means h is a height, is a smaller compared to radius of the earth. So h less than r, so purely under the force of gravity is called free fall. Here r is the radius of the earth. Go to next case, a body thrown vertically upward. So students, the person is standing here and throwing an object. This is a throwing an object upward. Object will be accelerated in the one direction. In the upward direction. From this point, it is the object moving reaching at the maximum point. After that, start a drop downward direction. So students, in the previous case, the object ground and object is moving positive y-axis. But in this case, this is my origin. This is my origin, and in this direction of some point positive y-axis. This is a positive y-axis, and make that accelerated due to gravity from this negative y direction. This is a negative y direction. Now see, this is positive y axis and this is negative y axis. So acceleration here minus g. Now here acceleration plus g. So student, now listen, we choose the vertical direction is positive axis, then the acceleration a is equal to minus g. This is a is nothing but a g minus g, and a g point, this is g point toward the negative y axis. This is a negative y axis. Now can be using kinematic equations. So listen in the velocity and position of the object at any time. So student, the first equation of motion, v is equal to, what is v is equal to u plus at. So now here what is a? Along positive y axis, what is a? Therefore a is equal to minus g. So a is equal to minus g, v is equal to u minus gt, and substitute in equation number 2, kinematic equation, s is equal to ut minus 1 by 2 gt square. So at the same time, velocity of the object at any position y. So student, third kinematic equation, v square is equal to u square minus 2gy minus 2gy. So student, this is the second case of motion of under the gravity. So okay.